Hello friends and welcome to a chat from the engineering desk. I hope you are all doing very well today. So I've got another experiment set up here. What I have over here is a hydrocarbon or combustible gas sensor. So that's a heated sensor, and if I bring some butane in this case near it, the voltage on the output is going to change. I've got it displayed on the meter over here. I'm feeding it into an Arduino over here, and I've got a flashing LED over here which is flashing slowly to indicate that there's not any flammable gas present at this stage. So I'm going to bring in a lighter like this. It is not lit, and we're going to hold it near the sensor, and as you can see, the LED started flashing faster and faster, and our voltage reading went up. So this thing gives us a voltage in proportion to how much flammable gas is detected by this heated sensor over here. Turn that back on. So it's a very simple setup. It's 3-wire. You've got 5 volts applied to this, and blue is your signal out. I'm taking that to analog input 0. Then I have an LED over here which takes a 5 volt signal in, which turns that transistor on and turns the LED on. So once again, 3 wires, 0 volts, 5 volts, and your signal. That's connected to pin 13 over here on my Arduino, where I have a little bit of a sketch running which reads the analog input 0 and produces a pulse to flash the LED in proportion to how much butane is being detected by the sensor. So what we do is we take this, demonstrate this one last time. Sorry, I bumped the camera there. But there you can see the flashing of the LED getting faster and faster as we get more butane onto the sensor, like so. Then the moment I take the butane away, that voltage goes down again. That goes down to about 0.7 volts, so you end up with a slow flash. So this you could use to monitor for things like carbon monoxide or propane or liquid petroleum gas and so on. That's how those sensors work. So let's have a quick look at the code. Let's move it over to the computer and I'll show you the code. And then I think we should also take a look at the construction of that sensor inside, how they work, because it's very interesting why it's got that screen on the top and what's going on there. So let's see you over the computer. Alrighty, so here I've got my Arduino Sketch open. Very simple. I used the example here, analog input. That's the example that I used. So what we got happening here is the sensor pin, which is the 0 to 5 volt signal from the sensor, goes to analog input 0. LED output to that flashing LED goes to pin 13, Sensor value is a constant in which we're going to store the value read back from analog 0. And then on a pulse value, which is 100 milliseconds, which is the on time. So that's a brief flash. So we make pin 13 an output, and here's our loop. Sensor value is analog read, sensor pin 1, or sensor pin analog 0. LED pin high, and then we wait 100 milliseconds. We then turn it off and we wait for another delay, which is where I've inverted it by saying 800 minus sensor value and then multiplying that result by 5, so that when the voltage back from the sensor is low, you get a nice slow flash, and then as it gets up to about 4 volts it becomes a fast flash. And that is what is happening in the Arduino code. Very simple stuff. Makes for a nice demonstration. So next let's have a look at what happens inside that sensor. Let me find a document on that and we'll talk about that. Right, so what I've got open here is the page from DigiKey, and there you can see the sensor which I've been using for my demonstration. So that's the different types: metal oxide, based gas sensor, optical, electrochemical, capacitance, calorimetric gas sensor, acoustic based gas sensor. Now in this case, it's actually a good question which one we have. I know that it gets warm, so I know that there is a heater coil in it, and it takes a while to stabilize. So yeah, it's got a potentiometer on it. That's a good question. Which sensor do we have? We have got not sure what the red sensor is. Either a 6 or a 2. We know that it detects the butane from a lighter. So what happens inside it is interesting. It generates a change in resistance, they say. Right. Tin dioxide is a sensing element. And the heater is a nichrome nickel chromium heater. The electrode line over there, there's a tin dioxide. So it produces a small current when the gas is detected. Interesting. there's various types of sensors, and I think that basically one has to do quite a bit of research on this to become familiar with all these types of sensors and what gases they're used for and how they work. But this is the long and the short of what's inside there. It uses a heater, and then the tin dioxide sensor, and you get a voltage out, and then one can use that for control. You can use it for warnings, all that sort of stuff. A MQ07 is a carbon monoxide sensor. Now that I've worked with, they use them in parking basements to detect the amount of carbon monoxide present and vary the speed of the ventilation fans in proportion to the carbon monoxide reading. So we feed that signal into a variable speed drive. We use the PID, where we have a set point for the maximum amount of CO2 or CO in the air that we want present without it being dangerous. So the fan will be stationary until you exceed that set point in the PID, where we're now going to draw in fresh air to get rid of the CO, and the more the CO, the more it speeds up the fans. The heating, ventilation and air conditioning companies with their building management systems generally employ that sort of control. So that's what's going on with our little sensor, and I think that we're getting fairly far into this video. We've had a play with this gas sensor. You saw how you've had a demonstration of how to wire it up, write a bit of code for it, make an LED blink to indicate how much flammable gas is present in the air or not, which is a nice visual indication, and you can do more with it. And I'm going to wrap it up here at this point. Thanks for joining me here today, ladies and gentlemen. This was another interesting one. There'll be more for sure. Take care, have a wonderful day, and we'll see you back here soon for more. Cheers.